And I mentioned some of the communications briefly, but what you have is a wide variety of technologies for communications outside the home, but also inside the home. And those all have to be meshed together transparently so all the communications occur without any delays. Now, from a single chip media processor viewpoint, what we see are what you need moving forward to be successful is first you want an optimized solution for each application. Okay, some companies are doing one big expensive chip and they're trying to sell it everywhere. Okay, where we say, you prefer to have a chip that's optimized for every market segment. So you're not paying for features and power and everything you don't need. The other thing we look for is dedicated audio and video decoding. Some solutions, they may have a very fast CPU on chip, and they may advertise a very high DMIPS rating, but they may take 10 to 20% of that CPU power to assist in decoding the video. But then, if you come across some video off the internet, which if the consumers are generating video, there's very little control over how that video is generated or whether it meets certain specifications. So there are high-definition movies out there that have a 90 megabit per second bit rate, which is 10 times what IPTV may use. And so you have to have a chip that will be able to handle that without degrading the applications running on the host CPU. Otherwise, it may affect things like the speed of the user interface response. On the 3D graphics, there's a big move on that to support very fancy user interfaces. Again, we feel that the performance of that should be tailored for each market segment. Instead of putting the biggest, fastest core on every chip, you should get what you need for your application so you don't overpay for anything. Flexible 3D video decoding and output. There's a wide variety of legacy 3D formats that are used. There are a lot of older 3D TVs already in people's homes, and so you really want to support them in being able to enjoy 3D content. One major thing we see moving forward is the video processing. Okay, and what we've seen in our labs is just because it's high definition doesn't mean it's the best video quality you can get. So we can actually make that look better. But also consumers still view a lot of standard definition content. In fact, that's the majority of the content people still watch. And so you want to make that high definition quality viewing experience. And I mentioned before the over-top content. A lot of that video quality is pretty questionable. So you want to make that look as good as possible for the viewer. The next thing is when the service provider starts offering 3D video, you want to be able to maintain the same video quality. Right now, if they do it, they have to lower the video quality a notch. And so we want to help them maintain the video quality so the consumer gets the best viewing experience. And power management, there's a lot of effort moving forward on that. Every country has its own set of rules and regulations. And basically, as a chip provider, we have to meet all those worldwide rules. And one thing to consider is that, if you have to add fans or heat sinks to the box or do a very complex box design in order to dissipate the heat, that increases your cost unnecessarily. And the other thing we discovered, for example, your mobile phone, there's only 2 or 3 reasons for that to wake up. If you have an incoming call or you push a button on it, it'll power up. But for a CE product or a set-top box, there's 10 or 15 different ways that has to wake up instantly and start working. Okay, content coming from the IR controller, RF over the Ethernet, over HPNA or G.hn. Okay, many ways for that to have to respond. So the power management becomes much more complex for these types of products. And then in addition, a while back we bought a company called Coppergate that specialized in home entertainment networking products. And the reason we did that is we see that you have to network all these things in the home. And as I mentioned before, not all homes are equal. So you may not have an Ethernet jack where you need it, or you may not have a coax outlet where you need it. You may want to have a product in the kitchen connected to the network. Okay, so we have all this technology for communicating over phone line, coax, and power line, and we have the ability to integrate all this technology on our products to help lower the costs for everyone. And as I mentioned before, the ability to support the home control and automation. Okay, that way everyone has that capability. So now the sales pitch. Okay, so for Sigma Designs, what we have is one of the deepest expertise in media processors for IPTV. So we're used to taking in content from a variety of sources over the internet or the broadband connection. We all have years of experience of playing back content from all your personal content in the home. And so basically, no matter what is out there, we're able to play it. And also with our network connectivity products, we're a leader in that market space. But what's most interesting is our ability to integrate the additional technologies we see that smart TV needs moving forward, such as the home security and energy management through our Z-Wave technology, and also our video post-processing technology. So this is an example of some 3D graphics, where basically on the top left side, you see a program guide where we're decoding 2 video streams, and you have a very fast, smooth-moving linear program guide. And on the right top side, you see where we can decode not only 1080p video, but 7 other video streams. And in real time, if you look at the center one and the bottom, we can take that video and we can manipulate it any way we wish. So we take the real-time video and we can wrap it around a Coke can, for example. And then in the lower, you see the example of possibly selecting a video-on-demand movie to watch, where you have a very nice user interface that's very pleasing to the eye. For the 3D video decoding and output, that can get very complex very quickly. As you see, there's a wide variety of 3D source formats on the market. Most of these are legacy. And you have everything from very simple, what we call side-by-side, okay, format that most service providers use now to transmit 3D, all the way up to what Blu-ray uses, which is the 2D plus enhancement scheme. And interestingly enough, that is the same scheme that a lot of service providers would like to use to transmit 3D video. Because with that, you can do full HD 3D without any loss of resolution. And then after all the processing and everything, you want to output in a variety of formats. Okay, there are 3D TVs that have been on the market for years already, so it would be nice to support those and not force consumers to buy a new TV just to watch some 3D content they found on the internet, for example. And so we'll have the ability to output in various formats. And for our video processing, we have the ability to integrate this on our products. We call it VXP. You probably have not heard of it because it's been pretty much focused on the professional market. Okay, we have a lot of studio application products that use it. And so basically what we're able to do is bring the studio quality processing down to CE products and set-top box products very cost effectively. And this gives you some idea of the capabilities. It's pretty standard, the 3D noise reduction, the block artifact reduction, mosquito noise reduction, motion adaptive deinterlacing. These are fairly standard features. The detail enhancement, adaptive contrast. So for example, one of our demos is we'll take test content off a Blu-ray disc and put on HDTV and show before and after processing with our VXP technology. And it looks, even Blu-ray looks a lot better after we process it. A lot more detail, a lot more contrast. But what we find most interesting is that this will also allow service providers to deploy full 3D HD video to the home without increasing bandwidth. So even today, service providers value their bandwidth very highly. Okay? And if they wanted to do full HD 3D to the home, they have to increase their bandwidth for a program by about 30%. But with using our video processing technology, they don't have to do that. And basically that allows them to take their 3D video to the next level of quality several years earlier than what they had planned earlier. So this is an example of our media processor architecture. It's basically a single chip solution. You have this plus some memory, connectors, and you have your solution. And basically what we do is we vary the host CPU and the number of video decoders and audio decoders, and some of the I/O is tailored to the different market segments. And I mentioned the network connectivity. You know, not every room has an Ethernet outlet, especially not in my house, okay? I wish it did. Or if it does, it may be on the wrong wall. And so basically with our HPNA and home plug solutions, you know, your phone line, your coax, your power outlets can all be network connections. And in fact, at one of our demonstrations that we have at our office is we stream 2 HD programs over the phone line. So just because it's a phone line doesn't mean it's bandwidth limited. And we also have G.hn in development. And so we have the capability of integrating all these technologies. And on the home control front, what's nice is that, you know, some of this the service providers can offer as additional services, such as monitoring your home security, for example. So if someone breaks into your home, they can be alerted and notify you and the police automatically. Or it could be as simple as just you receiving a text message on your mobile device. But we see this being implemented inside televisions, inside Blu-ray players, inside media players, etc., and set-top boxes. And basically, there's a range of capabilities available. We mentioned the security, the ability to adjust temperatures at the home. You can monitor energy management. So one big thing, especially in the United States, is the utility company may send you a message going, we're short on power. Please lower your power usage. And so you can go in and you can do that. And you can do it through your TV, through your cell phone, through your tablet, through your computer, whatever is convenient for you, from anywhere in the world. And on the home control front, you know, that's much more than just us providing a chip or software to the market. But you have to have a complete infrastructure available. And so what we have is based on Z-Wave, and there are more than 400 products on the market already around the world that offer a variety of solutions. And what's nice about the Z-Wave is that all the products interrupt with each other. Okay, there are no profiles where products from one profile will not talk to a product in another profile. All products are communicating in between each other. And so this is an example of a simple home security system here, where basically via any device anywhere in the world, I can monitor what's happening in my home. Okay, whether someone unlocked the front door or not. And a classic example is you want to monitor when your child comes home from school if he got home okay. And so when he unlocks the front door using his code, a picture can automatically be taken and you notified however you wish that he got home okay. And from an energy management viewpoint, you know, you can control and monitor your energy usage from any device from anywhere in the world also. As you can see, you can have nice user interfaces through the TV. You can have nice charts that plot your energy usage. And so, like, for example, I was able to find out that one of my dishwashers every night at 11 p.m. used a lot of energy. And it used more than anything else in my home. So that told me it's time to get a new one. And that's all I have.
Thank you.
Okay, thank you.